name is Tony Boyd, and I did my project on the HR diagrams of star clusters. To start, an HR diagram is a graph used to show the absolute magnitude or the luminosity versus the spectral class or the temperature of a star cluster. Stars that are higher on the graph tend to be more luminous, while stars that are lower on the graph are dimmer. And stars that are more towards the right of the graph are cooler, while stars that are towards the left are hotter. And these stars usually fall into 4 groups: the main sequence, which is where most of the stars are. Then they could become giants, supergiants, or white dwarfs. The point of my project was to find the age and the distance from Earth of a specific star cluster. A star cluster is a group of stars that were born around the same time from the same cloud of interstellar gas. And the star cluster I was given was M34, which consisted of about 43 stars. To do my project, I was given a program called CleaBio, which was basically it was like an online telescope that you can use to find like measurements of stars with. And then first I had to use the program to find all the blue and yellow magnitudes for each star in my cluster. And then using Excel, I entered all the magnitudes and subtracted the blue from the yellow to get all of the points in my star cluster. And here's a chart that pretty much, these are like, the yellow stars are all the ones in the star cluster. And then the pink ones, or I don't know, they're purple, that's the main sequence, and then the ones below them, like the darker purple ones, are the adjusted main sequence. And then the red line is the turn-off point of my star cluster. So to find the distance, I use the distance modulus, or the magnitude, or the apparent magnitude minus the absolute magnitude of a star. And then I use the formula d raised to the distance modulus plus 5 all divided by 5. And then we got 478.63 parsecs, which converted into light years was 1,560.3 light years. And then to find the age of my star cluster, I first had to adjust the turnoff point on the graph, which was that red line on the graph, to fit the turnoff point of my cluster. The turnoff point is the point on the HR diagram where the star is leaving the main sequence. And the main sequence turnoff point helps you find the age of the star cluster. Then you take the turnoff point and subtract it from the reddening to get the corrected turnoff point. And the corrected turnoff point estimates the temperature and the mass of your star. So I subtracted negative 0.01, which was my turnoff point, from 0.02, which was my reddening, to get a corrected turnoff point of negative 0.03. And this gave me a mass of 2.61. And then I used the formula T equals 1 over mass, which was 2.61, raised to the 2.5 all times 10 billion, to get an age of 90,865,439.3 years old. And that's all I got. So close.